Good evening, dear friends. In this video lecture, one will come across the information pertaining to the study of gas turbines and jet propulsion. You all know that in the course applied thermodynamics, gas turbines and jet propulsion play a very dominating role in the comprehensive study of thermodynamic analysis of thermal engineering equipment. You all know that a turbine is basically a prime mover or a self actuating device. One form of energy will be converted into the another form. But what particular form? That is what the question you will raise. A turbine is a self-actuating device that has the potential to convert pressure and kinetic energy of the fluid into mechanical energy. But mechanical energy alone will not help us to utilize the useful form of work. So, for a turbine, usually an alternator or a generator is coupled. Okay? Don't you really think the invention of a turbine is really amazing or fabulous? No doubt about it. You all know that there are various forms of turbine: steam turbine, gas turbine, water turbine, and whatnot. But in a specific category, one can find the sub classification. Okay? But in the course applied thermodynamics, we will not emphasize on steam or water turbine. We will normally accentuate on gas turbines. But before going to the epigrammatic overview of gas turbines and jet propulsion, one has to know a brief historical perspective. Can anyone guess when was the first ever turbine invented or developed? You may not get the idea, even the information is incredible. As I mentioned in the earlier videos, one person who has played a pivotal role in fabricating the engineering equipment or devices is Hero of Alexandria. In 50 AD, Hero of Alexandria was responsible for developing or fabricating a crude form of turbine. From 50 AD till date, we have seen many types of turbines. Okay, the invention of turbine is amazing, undoubtedly. Okay, but Hero of Alexandria, we may not have substantial evidence, but when we come to 16th or 17th century, many inventors were responsible for developing different types or versions of turbines. Friends, have you not come across the name Leonardo da Vinci? Leonardo da Vinci, Denis Papin, Giovanni Branca, John Barber, Cetibius, then many other people were responsible for developing many versions of turbine. When we just come to an example of water turbine, we come across Parsons turbine, John Wall turbine, Rateau turbine, Curtis turbine, where we normally study in a course called turbo machinery. Steam turbines and water turbines we normally study in a curriculum for engineering, a specific course called turbo machines. But in this particular video lecture, I will emphasize on the epigrammatic overview of gas turbines and jet propulsion. Then what is a gas turbine? You all know that the definition for any form of turbine is the same. But what is the working fluid here? In the case of a gas turbine, it is air. Okay? Whatever form of air used, it will be converted into useful form of gases. Okay? Alright. What is the principle of operation of a gas turbine? You all know that normally in the principle of operation of a gas turbine, we find four components. Which are all the principal components? One is the compressor, combustion chamber, next is gas turbine, the fourth one is the cooler. Friends, when you study the principle of operation of gas turbine, understanding refrigeration, compressors will be dead easy for us. Okay, that's why please thoroughly learn the principle of operation. Okay, in a very simple way, let me tell the principle of operation. Initially in a compressor, air is compressed. The magnitude of high pressure temperature air is passed to a combustion chamber. In a combustion chamber, due to the supply of heat, what normally will happen? Liberation of heat takes place. So, high pressure, high temperature air will be metamorphosed into high temperature, high pressure gases. Later on, it will come to gas turbine. You all know that a gas turbine has the potential to undergo expansion process. So, what will happen here? High pressure, high temperature gases will convert into what? Low pressure, low temperature, high velocity jet of gases. So, in the study of turbine, please make sure that we don't bother on high pressure, high temperature, we bother on high velocity. That is why when you learn the concept of turbines, compressors and nozzles will be very easy for us. Okay, this is all the simplicity in the principle of operation of a gas turbine. Okay, in the assessment or examination point of view, what one has to study, that is what the question you will normally ask. Friends, after knowing the theoretical operation of a gas turbine, we will move to the analytical aspect. You all know that when we studied the thermal analysis of heat engines, Otto cycle, diesel cycle, dual combustion cycle, we came across the derivation of thermal efficiency followed by mean effective pressure. In the similar style, we follow what? The derivation of thermal efficiency for a gas turbine. Friends, the derivation is very easy. Let me give a suggestive tip in learning the derivation. If you know the derivation for the thermal efficiency of Otto cycle, you will not find any difficulty in learning the expression for thermal efficiency of gas turbine. Okay, it is very simple. When you deal with the operation of gas turbine, we depend on something called ideal and actual Brayton cycle. Brayton is the name of a thermodynamicist who developed turbine, Georges Charles Brayton. Okay, so in his name we will study the operation thoroughly. Okay, let me give a tip. When you studied heat engines, fundamentally what ratio you came across? It is compression ratio. But when we deal with turbines, compressors, refrigeration, what ratio you have to bear in mind? It is pressure ratio. Okay, so that is very fundamental. When you solve problems in heat engines, you could come across temperature volume, pressure volume relation. But when you deal with the numerical problem in the case of a gas turbine, pressure ratio play a very fundamental role. So, you will be using temperature pressure relation. How to start the derivation? You furnish pressure volume and temperature entropy plots. In the pressure volume and temperature entropy plots, what are the four processes you deal? Very analogous to Otto cycle. In the case of gas turbine, the entire operation is based on constant pressure process. Two isentropic processes, two constant pressure processes. You remember Otto cycle. It comprised two reversible adiabatics, two constant volume processes. But here it is constant pressure. Okay. So, two constant pressure, two isentropic processes. So, for every process, you carry out the analysis. ultimately, what is the expression you are going to get? You remember eta thermal for Otto cycle. What was the expression? 1 minus 1 by Rc to the power of gamma minus 1. What was Rc there? It was compression ratio. But here it will be eta thermal gas turbine equal to 1 minus 1 divided by Rp to the power of gamma minus 1 by gamma. What is that Rp there? It is pressure ratio. If you know the supreme distinction, solving problems will be dead easy for us. Okay? So based on this, we categorize ideal and actual Brayton cycle. Whichever problem you solve in gas turbine, we normally use what? The TS plot for actual Brayton cycle. You will ask me, what is the distinction between ideal and actual Brayton cycle? Ideal, just 4 processes. Process 1 to isentropic compression, process 2 3 constant pressure heat addition, 3 4 isentropic expansion, 4 1 it is cooling. But here 1 2 1 2 dash, 3 4 3 4 dash. Okay? When you just see to the lecture notes, related video or study material for gas turbine, you can very easily understand what? The analysis of gas turbines. Okay? So friends, please bear in mind here the points 2 4 depict what? Ideal temperature. But 2 dash 4 dash depict what? Actual temperature. So in solving any problem, please bear in mind one should be aware of compressor efficiency, turbine efficiency. So actual work done by a turbine, actual work done by a compressor. If you solve these 4, definitely you can solve what? Thermal efficiency. How you will calculate thermal efficiency for a gas turbine? Very simple. What is the basic definition? Work done by heat added. That is for the case of heat engines. But how do you calculate eta thermal? Work done by a turbine minus work done by a compressor divided by the maximum value. Okay. So please bear in mind the thermal efficiency of a gas turbine will be low when compared to IC engines. Okay. So that information bear in mind. Very similarly, you can calculate work ratio. How can you calculate specific work ratio? Work done by the turbine minus work done by the compressor divided by work done by the turbine. Please bear in mind, in the case of gas turbine, work done by the turbine will be more than work done by the compressor. If you remember this mantra, you can do any tantra in solving the numerical problems. Okay. This is the first part in the case of gas turbines. You will question me, okay, till now we have come across the definition of gas turbine, brief historical perspective, then the principle of operation of a gas turbine very particularly. We don't study steam and water turbines in applied thermodynamics, we study in turbo machinery. That has been clearly highlighted. Next, we have come across the thermal analysis of gas turbine using ideal and actual Brayton cycle. Okay. Please remember, throughout turbines, we deal with what? Pressure ratio. Turbines, compressors, refrigeration. If you take up any module, pressure ratio is the dominating force. Okay. Alright. Now, the second segment in gas turbines. You will question me, are there any methods to enhance the thermal efficiency of gas turbine? You just said that the thermal efficiency is very low when compared to IC engines. In the case of IC engines, take the example of petrol engine. The thermal efficiency will range from 35 to 40%. That is in the case of diesel engine. When you take the case of petrol engine, 25 to 30%. But will you believe it or not, the thermal efficiency of gas turbine ranges between 15 to 20%. That is all. That is why very habitually we don't use gas turbine for power generating units. We use steam turbines. You take the case of hydel power plants, we use water turbine. You take the case of thermal power plants, we use steam turbine. But gas turbine and the thermal efficiency is very low, we don't prefer. Okay, but there are three suggested methods to improve the thermal efficiency of gas turbine. Marginally, the thermal efficiency will increase. Then, what are the three methods? Very simple. The number one is what? Intercooler based gas turbine plant. Friends, if you need to learn this intercooler based gas turbine plant, bear in mind you should know the flow diagram and temperature entropy plot. You did not write the concept in the case of actual and ideal Brayton cycle? Yes, we did it. So, in the case of TS plot, 1, 2, 2, 3, 3, 4, 4, 1. That is the mantra you need to remember. But here, in the case of intercooler based gas turbine plant, please bear in mind what are the four components in a gas turbine plant. Usually we take up compressor, combustion chamber, gas turbine, cooler. But here, if you are taking intercooler based gas turbine plant, remember we will use two compressors, one combustion chamber, one gas turbine, one cooler. Why two compressors? What is the logic here, friends? We will be using low pressure and high pressure cylinders. Directly, it is not possible to get high value of pressure. Okay, therefore, when an intercooler is incorporated between low and high pressure cylinders, it is possible to develop high pressure air. Okay, so intercooler is incorporated between low and high pressure cylinders, thereby high pressure air approaches combustion chamber, gas turbine, cooler. That is what the flow process you need to remember. Okay. So intercooler based gas turbine plant, one has to properly write the flow diagram and temperature entropy plot. If you know the concept of actual Brayton cycle, then it is very easy. Okay. Regularly we follow one compressor, one combustion chamber, one turbine, one cooler. But here it is a special case. If intercooler comes to picture, low and high pressure compressors come to the idea. Okay, so please bear in mind the same idea you even study in reciprocating air compressors. In one of my videos, it has been strongly focused expression for the minimum power required to drive a two-stage air compressor. I have already done the idea there. So the same idea here also it is applicable. If you know here, reciprocating air compressors will be dead easy for us. Okay, alright. This is the first method what we need to take up. When we come to the second method, what is that? Reheater based gas turbine plant. What is that reheater based gas turbine plant? Friends, it is exactly the opposite to intercooler based gas turbine plant. What is that? In the case of intercooler gas turbine plant, between low and high pressure compressors, intercooler was juxtaposed. But in the case of reheater gas turbine plant, what is the idea? You can have a speculation. Yes, you are right. Here you will be using one compressor, one combustion chamber, two turbines, one cooler. Okay. So what is the idea here? There we used low and high pressure compressor, but here what is the idea? The pressure and temperature should decrease. Attenuation should happen. Therefore, between high and low pressure turbines, we use what? Reheater. Okay. So what will happen? Because of the reheating process, high pressure, high temperature gases will be converted into low pressure, low temperature gases. What is our objective? Our rationale is to develop high velocity jet of gases. Okay. So intercooler is done, reheating is done. Who is the third character? He is the regenerative gas turbine plant. Friends, the name regenerative or regeneration is not new for us. Why? Because we have dealt already in heat engines. What is that? It is the study of thermal efficiency of Stirling engine. Stirling engine, regenerative cycle. Even in the case of vapor power cycles, have you not come across regenerative cycle? Yes. Even in the study of gas turbines, we deal with regenerator. What is that regenerator? It is colloquially an heat exchanger. Okay? So in between these components, we use what? Heat exchanger. That is all the methods what we need to study in the improvement of thermal efficiency of gas turbine. This is a very commonly asked question in the examination. Okay? Intercooler, reheater, regenerative gas turbine plants. You have to learn the flow process or flow diagram followed by temperature entropy plot. Yes, now there is a question. Independently, we have come across the methods. Is it possible to use all components in a single unit? Yes, that is possible. You have separately learned intercooler, reheater, and regenerative cycles. It is possible to amalgamate all units into single gas turbine unit. So intercooler, reheater, regenerative, all three in a single unit. Even you have to practice the flow diagram followed by TS plot. Okay? So when you all study these theoretical details, you don't find any sort of difficulty in solving the problem. Remember, the problems on turbines and compressors are dead easy. You don't find very esoteric procedure in solving the problem. Okay? So friends, this is all the theoretical ideas what one has to study. Okay, can you give some tip or tips in solving numerical problems on gas turbines? Yes, very easy. Friends, you should know that in solving any problem on heat engines, compression ratio played a dominating role. Okay, for that, temperature volume, pressure volume relations are very important. All right. Similarly, when you need to solve any problem on gas turbines, what is very important? Pressure ratio. For every problem, pressure ratio will be given. Thereby, you use what? Temperature pressure relation. Okay. Also, get well acquainted with compressor efficiency, turbine efficiency, then the definition for mass flow rate, the definition for power, the expression for thermal efficiency and specific work ratio. If you know these things, you can be familiarized with any variety of problem. Okay? So anyhow, in the coming videos, we will strongly stress upon that. No problem. It is all about gas turbines. Friends, along with gas turbines, one has to study a small topic pertaining to jet propulsion. Children, usually in the advanced level of thermodynamics, jet and rocket propulsion is a separate course for the students. But here, you don't deal with rocket propulsion, you study with jet propulsion. Jet propulsion basically the theoretical idea. That's it. Why? Because the numerical problems are very cumbersome. It is very elaborate. Okay. For the undergraduate level, you just deal with the theoretical operation. So what basically one has to be familiarized in the case of jet propulsion, one has to study the theoretical operation of ramjet, turbopropeller, turbojet, and the theoretical operation of rockets. Okay. Usually in the examination, a student belonging to any university, please bear in mind, one theoretical question from jet propulsion they normally ask. Okay. With a neat sketch, explain the principle of operation of a ramjet, turbopropeller, or a pulse jet, or with a sketch, explain the principle of operation of a rocket. So friends, on learning gas turbines, you have to compulsorily study the theoretical details of jet propulsion. This is all the information what one student has to agglomerate. Okay, I think this video may be beneficial for all. For a minute, let me quickly summarize the information. Anyhow, in this video, I am covering the topic gas turbines and jet propulsion. Alright, so in the study of gas turbines, definition, brief historical perspective, theoretical principle of operation, then the thermal analysis of gas turbines by employing ideal and actual Brayton cycle. This is one segment. In the second segment, what did we come across? The three prominent methods to enhance thermal efficiency of gas turbines that we have come across. Thereby, any individual will be in a position to solve the illustrative problems on gas turbines. The final segment is what? The theoretical study of jet propulsion. This is all what one has to learn in gas turbines and jet propulsion. Okay, I hope this video may be really resourceful. Thank you very much for giving me an opportunity in sharing information with you all. Thank you very much. Good luck.